We have a test tomorrow on Wednesday the 28th, sections 5-9 to 6-3. It will cover imaginary numbers. We said imaginary numbers are just like variables. When you're adding and multiplying, you have the same rules. Just when you get to the end, you want to simplify any I term. I squared is the same as -1, so we are looking to see how many -1s there are in I to the 32nd power. Well, there are 16 I squareds, which means there are 16 -1s being multiplied. You multiply a negative number an even number of times, and the answer is positive. In I to the 30th, there are 15 I squareds. When you multiply a negative number 15 times, the answer is still negative. And if I is to an odd power, we know that there will be an extra I in the end. We separate and see that there are 7 I squareds in I to the 14, which is odd. Therefore, it's -1 times I. We're also testing on graphing parabolas. If you recall, we said we tell if it opens up by looking at the sign of the x squared term. If a parabola opens up, it has a minimum value. If it opens down, it has a maximum value. The axis of symmetry can be found with the equation x equals -b over 2a. The axis of symmetry, remember, is the middle of the parabola. The vertex sits on the axis of symmetry, so x is the same value, and you find the y-coordinate by plugging x back into the function here and figuring out what y is equal to. Also, if you're asked to find the minimum and maximum value, that would be the y-coordinate of the vertex. And the y-intercept is always your constant term. Don't change the sign, just whatever it is. If c is positive, your y-intercept is positive. If c is negative, so is your y-intercept. We'll begin with number 1 on the pretest. I'm going to work through the odds. You are going to do the evens tonight. The answers are at the end of this video for all of the questions, but I'm going to work through and show you exactly how to work them. First off, there's nothing different in simplifying this radical except identifying that this is not a real number. Because of the fact that it's the square root of a negative, I'm going to say or identify that this indeed is an imaginary number. Once I have identified this is imaginary, there is no more need for this negative. Now we go about simplifying the way we always did. We take 242 and break it down to its factors, which is 2 times 11 times 11. Since we are under a square root, we are looking for any pairs of numbers. And since we have a pair of 11s, we can remove that from under the radical. For x to the 16th power, there are 8 pairs of x's, leaving me with none under the radical. And for y to the 20th power, there are 10 pairs of y's, leaving none under the radical. The only thing left under the radical is a 2. So the answer to number 1 was I times 11x to the 8th, y to the 10th, square roots of 2. Skipping down to number 3, in multiplying these two radical expressions together, because they're both square roots, we can simply combine them. But first we must identify that in the square root of -200, that is an imaginary number. I identify imaginary and the negative is no longer necessary. Same thing here. I have an imaginary number and the negative is no longer necessary. Now I take 200 and 300 and I factor them to see what can be removed from under the square root. 200 is 2 times 10 times 10. You can break that 10 down further, but when you put it back together, you're still going to have 10. If you have a pair, then you remove it. There's a 2 left under. Here, this is 3 times 10 times 10. Since there is a pair of 10s, I can remove it, and there's a 3 left under the radical. Now, when you multiply I 10 square roots of 2 times I 10 square roots of 3, it's I times I, which is negative 1, because it's I squared, 10 times 10, which is 100, and under the radical, 2 times 3. Notice there is no more I. I squared simply multiplies everything by a negative 1. The answer to number 3 was negative 100 times the square root of 6. For number 5, using your calculator, you should get 28.478 for your answer. Please make sure you know how to use your calculator to work those types of problems for tomorrow. Skipping down to number 7. Between the parentheses, you see an addition sign, which means that you are adding the terms in those groups. We can basically, because it's nothing but plus signs, drop the parentheses. So it's 6 minus 14i and positive 19 minus 10i. Now the reason I regrouped is because I want to show which ones are alike, because I can only add like terms. Here 6 plus 19 is 25. Remember, we treat I as a variable. When you are adding variables, you do not change the exponents. You simply identify the terms that are alike by the letter on the end of it, and you add the coefficients. The answer to number 7 was 25 minus 24i. Number 9 is a multiplication problem because between the two sets of parentheses there is no plus or minus. We have to do FOIL. Can you tell Daddy he's going to get Katie? When we do FOIL, we multiply first times first. 2 times 8 gives us 16. Our two outer terms are 2 times negative 9i. Our two inner terms are 3i and 8. And our last terms are positive 3 times negative 9, I squared. But as we said before, I squared is a negative 1. So when you multiply it, it simply changes negative 27 to plus 27. And we finish this off by adding our like terms. We have 16 plus 27, which gives us 43. We have two I terms, which can be combined. Negative 18 plus 24 is positive 6i. The answer to number 9 was 43 plus 6i. Number 11, nothing can be added, nothing can be divided. But we do need to remove the I from under the denominator. We do that by multiplying by the conjugate of the denominator, which is 2 minus 13i. And remember, what we do to the denominator of a fraction, we must do to the numerator to make it equivalent. In the numerator, we will distribute 8 times 2, 8 times negative 13. In the denominator, using FOIL,